Hello everyone, this is Dilip. This is a continuation from previous video. Let's look at hashing use cases. The most widely used hashing use case is hash tables, where given a keys like this, the names of people, we can map them to their house numbers. So here you can see John Smith. This we pass into our hash function, which will calculate based on this key a value which into the bucket, which is called hash bucket. And from that bucket, we can get the value, the house number of that person. So here is an example of collision as well, where given John Smith as a key or Sandra D as key, you are going to the same hash bucket. So in this case, in the usual in Linux implementations, what we do whenever this collision happens, we put a linked list in such a manner that once the name doesn't match, say we are searching for Sandra D. So Sandra D doesn't match with John Smith, we go to the next element in that list and then we find a value. So since collisions are less, this linked list sizes usually won't be that much big. So this is one major use case of hashing. Let's move on. Whenever you give your password or when you sign up and save your password in any website or in your local Linux machine itself, it won't be stored in plain text. It will be stored in hash format. Remember I said earlier, it is not possible to get the inversion from hash function. So given your not encrypted, but hashed password, it's not possible to get your plain text password. So even if you are signing up for Gmail or any other website, your password will be stored in their servers in hashed format only. So that if any hacker gains access to their servers, what they see is only hashed value of your passwords. They will not see the plain text anywhere because it's not even stored at all. And what happens when you enter the password? What they do is they convert it into the hash and then they match that hash value with the stored hash value. And if it matches, they will allow you to log in. So here you can see a picture of /etc/shadow in Linux, where it is storing the usernames and passwords. So right now, even in /etc/shadow, I don't think you can see the passwords like this, but there you will see some letter X written over there. It means it's encrypted and stored somewhere else. So that's how you can see. Earlier in /etc password itself, they used to store, but then it moved to /etc/shadow in Linux, and then it's moved to some other place. This is the latest use case which is being used for hashing, which is blockchain. If you are aware of cryptocurrency, you might have known about Bitcoins, all these things. So most of them use this hashing for their transaction validation. So if you are using blockchain, you have to use some hash. So I have taken a simple example of blockchain with SHA-256 hash. So Bitcoin works using the SHA-256 hash only. So what happens, how this SHA-256 hash is used to secure this blockchain. So whenever you have a data in this block, what you do is you calculate the SHA-256 hash of this block and you input that SHA-256 hash to this block. Now this block will contain some other data, but it will also contain SHA-256 of the previous block. Now, again, you will calculate SHA-256 of this whole block. Now, this block will contain all its data and SHA-256 hash of this as well. Now, what happens if you modify the data in this block? Say some secure data is there, you have modified the data. So some X is there, you made it to Y. Then what happens is, once you modify this data, it won't match the hash value stored in this block. In this way, modifying this block will make this chain go haywire. And similar way, the one block after it, since it has the hash value stored of this block plus this block, its calculation of SHA-256 hash also will go haywire. So in this way, entire blockchain will become invalidated. So that's the reason blockchain is considered a secured way to conduct transactions as of today. But there are miles ahead. Still, our banking and all our systems have to move to blockchain. It's not yet done as of today. So that's it for today's video. Thanks for watching. Bye.